In this video, we're going to take a look at activity 3.1.5 called Variables and Functions. We're going to be using the Vex v5 test bed and the Vex Code v5 software to look at how we can use these things to allow for complex control of a system and do a few things like make some of our programs a little bit simpler and expand what we can do with our programs. So the first steps we're going to walk through are going to be how to make a variable, name it, explore what are our new variable blocks that come up and happen when we do this, and then we're going to build a program that will, utilizing our variable, we're going to loop that program only a certain number of times and then have it stop. So that's going to be what we have happen there. And so that's going to be what we look at. So here's our program we'll start to build, and we'll move on from here. So I'm going to go ahead and go into Vex Code. When we go down to variables, so I've already kind of played around with this. I'm going to go ahead and delete the variable that I have. So I'm going to go ahead and choose make a variable when I'm ready. We're going to do motor count, and I'll hit submit. If you mess up spelling or need to delete and create a new one, you can right click on any of the variable names and rename or delete the variable like I did at the start there. So you'll see our new variable blocks that show up, and what they want us to do is I'm going to go ahead and grab a comment block up here, and we're going to start building out. This is the part 1 provided code. We're going to go ahead and start off by setting the initial value of our variable. They want us to change that to 1. So anytime we use a variable, we need to have an initial value that we want that variable to be set at. So once we do that, I'm going to go up to the control section, grab the while block, set up an operator to where we're going to say that it's going to be less than. And what we want to do in the variable is we want to bring our motor count variable into that operator. And we're going to change, while the motor count is less than 4, we want to have a loop that sets up that's only going to loop these commands that are going to show up in the while loop 4 times. From there, I'm going to go ahead and I can start building some of my commands that I want to see happen. So I can go ahead and say to spin the right motor forward for 95 degrees. I can then, while I'm up here, I'm going to go ahead and grab the stop motor and change it from left motor to right motor. I'm going to go down to the looks. We're going to, while we're working our way down, we're going to grab a print Vex Code on the brain block. We'll throw that in there. Now, for this to show up on the video, I'm going to go ahead and change the set font to a super large on the brain. So this is just a print setting that'll kind of go with the print that we have going on. Then I'm going to move down to control. I'm going to grab a couple of weight blocks that'll go in between our blue blocks here. Those are going to get changed over to 2 seconds. And then after that, we're going to go back down to our variables, and we're going to have it print the motor count variable, or the amount of times it looped, and then we're going to go ahead and change the motor count by 1, which means as we look at this program, is it sets the motor count variable to 1 to start off, and then it goes into the while loop, and it'll enter in, it says while the motor count is less than 4. Well, the initial value is set to 1, which is less than 4, which means we're going to go ahead and we're going to spin the right motor forward for 95 degrees, wait for 2 seconds, stop it, wait for 2 seconds. We're going to print the motor count on the brain, and then the motor count is going to get an increment added to it by 1, so then it becomes 2. Well, then it goes back up to the while loop condition, and since 2 is less than 4, it's going to run all these commands in order going down, and then it's going to come back up, it's going to loop again and check to see if it's less than 4. Once it sees that it's not less than 4, then it's going to stop the program. So let's go ahead and download and see what effect we get, and when I hit run. So there's one of the actions. One of the times that it looped, it printed a 1 on their brain there. It did it again, so we're going to run 2. And then here we see a 3. So as you go forward, it's like, okay, well, why didn't it print a 4? Well, some of it depends upon the print, where the print is going to be at in the program, which as you go through the activity, they say that putting the print statement where it's at will go through and kind of not show a number 4. So what I'm going to do is I'm actually going to grab this out. Let me put the increment back in. Let's change the position of where the print statement. Let's have it do it after it's already counted. So let me download and hit run. You'll see it'll skip 1, and now it goes to 2 because 1 was already there. It had to add 1 and then it printed, and now we'll see 4 show up here in a moment. So that is what moving that print statement, just by moving the order, we're able to see kind of what happens. And that's kind of what we're going to do in this case. I'm going to go ahead and move this set of commands up so that way it's above the spin motor. Let's download. Hit run. So this goes through and produces the same result as what you had, as what we did from the very first setting. Now, let me go ahead and grab this. Let me move this set of commands in here. Let's put it after the while loop. Let's download. Hit run. So what we're going to see is putting the print statement at the very end after the while loop only shows after the loop is completed, so after it runs 4 times, and so we should see a 4 show up there on the screen. Last setup, if we move this print statement, we're going to put it right underneath the set value to 1. If I download and hit run, all I'm going to ever get out of it is going to be the value of 1, even though it's going to run because it's already executed through the commands, and now it's down into the while loop, so it never comes back up and prints a second, third time, or any other time. So here's some other things we can do. Is I'm going to go ahead and disconnect these. Something you can also do is by going through and setting that there. If we also set our motor count to 0, I can download and hit run. So when it starts at 0 and then gets added to 1, you'll see there is 0 gets shown, and then 1, and then 2. So, and then 3. So those kinds of things can go through and be seen, and of course, if I change around, let's put this motor count and then set the print statement underneath it. Let's hit run. So now we'll see 1. And now we'll see 4. So depending upon, how you set this up, usually I like to start with setting an initial value of 0, and then that way we actually see the 1, 2, 3, 4 get counted as we move forward. So, all right, as you move around that print statement, you can try that out and see what kind of results you get just by moving it in different areas. To finish out this activity for part 1, we're going to run a motor backward and forward 20 times, a half a second each way, and then use a print block to show how many times the motor is run back and forth. Now 20 times is quite a bit. It's a little bit more than 4, and you would have to set up a lot of other blocks here. So I'm probably going to go through and change the position of the print block from where we had it, but I'm going to go ahead and build that code that we have. We're going to set the motor count to 0. We're going to go ahead and make sure that it loops 20 times. I'm going to go ahead and grab this list of commands out, and I'm going to start building my code. So I'm going to go up to motion. I want to spin the right motor forward. I want to, so I can get rid of some of these blocks here. I want to get rid of the spin for 95 degrees. I'm going to go ahead and just grab this wait statement, change that to a half a second. I'm going to spin the right motor going in reverse. I can get rid of the stop motor command. And then I'm going to wait for a half a second. And then I can change the motor count by 1 and then have it go through and print on the brain. So, however, rather than it counting all the way across and adding in a lot of kind of necessary things, I'm actually going to move the print statement after it's completed the loop, and then that way we can see the effect. So let's go ahead and download and see what we get. I'm going to go ahead and, before though, I might want to do this just to get a little bit more effect. Let me set the right motor's velocity to 50%, and then let's download again since we made a change to the program. Okay, so once it finishes the loop, you'll see 20, it gets printed on the brain, but here's a little issue, is our motor gets caught in a continuous loop, so we don't necessarily, it just continues to run. So I need to grab a stop motor command. I'm going to set that at the end of our loop once it's done running. Make sure I stop the right motor. Let me download, and let's go ahead and run that one more time. Okay, now the motor stops. We get 20 loop. It has been looped 20 times. We see that printed on the brain, and this will finish out activity 3.1.5 part 1, and in the next video we'll take a look at part 2. So let's go ahead and go to File, Save As, and actually part 2 has an A and a B section. So I'll go ahead and we'll name this 2A, and I'll hit Save. And then I can get rid of this part 1 code, but we'll use that again in activity 3.1.6, open and close loop systems.